Today we'll be talking about the water quality standards here. So you can see how to find the water quality standard for groundwater and the water of the nearby water bodies. So you can see here we are having a specialized government website especially for the water quality standards and how to handle the water pollution, how to find the suitability of the water for drinking purpose, for the purpose of the different industrial use. So especially this one is talking about the groundwater quality. So depending on different regions, we can find the quality of the water in the different zones here. So you can see here, this website is given by the Government of India as the Central Groundwater Board. So this is a board of the central government, that is a CGWB, Central Groundwater Board. It's again called as the Ministry of Jal Shakti, Department of Water Resources, River Development and Ganga Rejuvenation, so especially related with the purification of the Ganga River water also. So you can see here, basically we can find the assessment of the groundwater. That is the first one. We can go here for assessment of the groundwater. Then block-wise groundwater resource assessment that has been done in 2017. It can be found here. Second one is a dynamic groundwater resources of India. And third one is a report of the groundwater estimation committee. Similarly, the second heading here, we can find the augmentation of groundwater that is given by the master plan on artificial recharge 2013, the manual of the artificial recharge structure, demonstrative artificial recharge projects and artificial recharge plan here. Third one is the water quality standards. So in water quality standards, we can see here we are having the water quality and standards. Overview of the groundwater quality, areas where the groundwater storage of water management, right? So in this way you can find all the details of the water. Let us wise groundwater resource assessment. We can click here and then we can go to the assessment here. So we can find for the different blocks what is the quality of the water here. If we are clicking here, see here is given as the categorization of the AU.pdf. This is again the government site, and you will find the total PDF file. And this will be talking about the water quality of the different blocks of a district. That means you can go to the block level and find the quality of the water. That means which block is having the better quality water, which block is having the whatever contamination, where we are having the higher load of the dissolved solid and suspended solid in the water, right? Like here, you can find the starting from the alphabetical, like Andaman and Nicobar. You can see here the different blocks are given and which water is safe, which water is having the some quality. Like this one is the East Island is having the saline water, right? So similarly, you can find for all the different zones the what is the quality here. Like in the Andhra Pradesh, the Anantapur, it's showing over exploited, right? Here it is semi-critical. In Andhra Pradesh, the Anantapur and Atmakur is having the quality of the semi-critical. Similarly, you can see for the different all the states here. So you can go here and find the quality of the different. We will find the water here. For example, if you are seeing for the Punjab state, then you can go for Punjab here. And in the Punjab again, we are having the different district like Punjab, Sopar, Sangrur. So you can see here in Sangrur, it's showing the water is over exploited. right? That means the groundwater level is going down. It's being over exploited mainly because of the irrigation purpose. For agriculture, intensive agriculture is being done here in the Punjab, and the waters government website is showing the over exploited here. So you can see for different area, like in the Sunam against over exploited, Dhuri, then Tarantaran, all the areas basically it's showing the over exploited in the. Similarly, in the Rajasthan also it's showing the over-exploited area. And some areas are showing the safe, and some areas are again having the semi-critical. So you can find the areas in which the water is semi-critical, like here in the Ropar, in the Punjab state, in Ropar district. This area, Anandpur Sahib, it's water is not good quality. It's showing the semi-critical quality here. That means the water is not safe for drinking purpose, maybe critical, and we have to do the lot of the purification or treatment before using for the drinking purpose. Similarly, in the Pathankot again, you can find out here in the Pathankot, it's showing the semi-critical. Right, so mostly it's over exploited. So in this way, we can find here, like in the Mohali again, it's showing the two areas, Harar and the Deravasi, it's having the over exploited, whereas the Sialva Majri is safe basically. In Muktsar again, the water is safe, it's good quality. And you can see here in the Mansa area, Punjab, in the Mansa district, and the Junir, this is the block basically. Here the water is having the critical quality, that means very poor quality. So a lot of the purification and treatment will be required here. Similarly, in the Hoshiarpur again, it's in the Talwada and Mukeria, it's showing the semi-critical. So in this way, we can find out the quality of water in the different areas, in different states. You can go for the different district and block wise. So we are having the good data bank here. It's stored here, and you can refer it before setting up the industry or even for handling the water problem. In the different zones of the country, we can see the government data here. What is the another here is second one is the water quality standards. So what is the water quality standards given by the ISO 10500 2012. So you can see here it's talking about the quality that is required for the drinking water. Right, so this one is the table 6. That's talking about the bacteriological quality of the drinking water. So you can see here. So it's talking about the basically E. coli, the bacteria that's found in the water. So coliform bacteria, and so this will not be detectable in any 100 ml of the samples. If you are sample having a volume of 100 ml, this will not be any presence of the coliform bacteria. Otherwise, it is not suitable for drinking purpose. Similarly, for the treated water entering the distribution system after treatment, when it's coming to your houses, schools, hospitals, for drinking purpose. And again, here the E. coli or the thermotolerant coliform bacteria, this should not be present in 100 ml of the sample volume, and total coliform bacteria again should be nil. And the second one is the treated water in the distributed system. So again, there should not be any presence of the bacteria here. That is the first requirement for the drinking water. Mainly, these waters basically should not be having the contamination. Causing the diseases in human beings, and that's why it's required to have nil presence in the given sample. Then talking about the biological requirement here, you can see here. So ideally, all the samples taken including the consumer's premises, should be free from the biological organisms, especially for drinking water. And biological examination is of value in determining the causes of objectionable taste and odor in the water. If there is some presence of biological impurity, basically it will be causing the bad taste and odor. The smell will be coming out, and helping to interpret the result of the various chemical analysis and explaining the causes of clogging in distribution pipe and filters. That's why it's required to have the treatment if there is any such type of organisms present in the water. Sometimes here again talking about the viruses again, here viruses are generally resistant to the disinfectant as well as get protected on account of presence of the particulate and organic matter in water. So it's difficult to treat the viruses because of the difference between the resistance of the coliform organisms and of the virus to disinfection by oxidants increases with the increasing the concentration of reducing components. For example, organic matter, it cannot be assumed that the absence of available coliform organisms implies freedom from active virus under circumstances where the free chlorine residual cannot be maintained. So sedimentation and slow sand filtration in themselves may contribute to the removal of the virus from water. Right now, the point is how much should be the residual chlorine after the treatment. So in practice, it should be less than 0.5 milligram per liter of free chlorine for 1 hour is sufficient to inactivate virus. Right. So this much of the chlorine 0.5 milligram per liter. This is the minimum amount. This much amount should be available, and that is for 1 hour is sufficient to inactivate the virus even in water. The water is free from particulates and organic matter. That's a main condition. That means you can deactivate or inactivate the virus, but the point is it should be free from the particulates and organic matter. This will be basically providing the protection to the virus here. Mentioned in the previous paragraph here. Basically, this type of materials provide the protection to the virus. And again, the chlorination at the dosage normally implied in the water works. Mostly we are doing the chlorination in the water for removal of the infection. So it is ineffective against certain parasites. That means even the chlorine cannot kill such type of parasites, including the amoebic cyst. So based on the amoeba type of the parasites, this cannot be killed by the chlorine. They can be excluded only by effective filtration or by higher chlorine dosage than can be tolerated without subsequent chlorination. So it is more effective will be the filtration process here for removal of the amoeba type of the parasites. So amoebiasis can be conveyed by water completely free from intake bacteria, and the microscopic examination after concentration is therefore the only safe method of identification. You have to go to the microscopic examination.